Okay, so here's some important formulas that you guys should know. This one right here is for compounding a bunch of different times during the year, and this one's for continuous compounding, which is kind of interesting. There's a proof for it and how we get E, but today the purpose of me showing you guys this stuff is to show you guys some exponential functions and how they look, how they behave, how do you graph them, how do you plug numbers into them. Now, there's a couple of letters up here that you should know. A is the balance, the current balance. I should say current right here. Oh, man, my writing is not that neat on here. Current balance. Let's see. P is the initial deposit. I'm going to say initial amount. But initial deposit would also work. Initial amount. That's the beginning. That's what initial means. Initial means the beginning, the starting. Okay. R is your rate. Now, normally in a problem, that's normally given as a percent, but you need to change it into a decimal. Most formulas do not use the percent of it. They change the percent back into a decimal, and they use the decimal for the problem. N is the number of times compounded. Now, when an amount is compounded, that means the interest is added to it. And so N is the number of times it's compounded per year. There's one more I'm forgetting, and that's the T. T is time, and it's always in years. All the problems that we'll be working on are always in years. Okay, so let's look at the first. The first example I want to look at is just with you guys. Okay, let's pretend you guys have $1,000 and you drop into a bank account that has 2.5% interest, and that compounds annually. Okay, and you put it in there in 2013. How much money does the account have in this year right here, 2033? Now this compounds annually. So which formula are you guys going to use? The first one or the second one? This one says the number of times it compounds. This is continuous compounding. We're going to use the first one. Now, how many times does this one compound? It says annually. So how many times every year is it going to compound? Once. It's going to compound once a year. And so let's write it out. I want to write the formula out and get you guys going here so you can start plugging stuff in. So it's what was it? A equals P times 1 plus R divided by N raised to the N times T. Wait, is it N times T? Yeah, it's N times T. Okay, now we said that N equals 1 because it compounds once a year, right? So N equals 1. Do you guys know what R equals? R is our rate. What's our rate in this one? 2.5%, which is the same as 0.025. Remember, we need to change it into a decimal. There's another variable that we know. What is it? We know this variable. It's the P. Initial amount. What's our initial amount for this problem? 1,000. That's what we're putting into it. Okay, so our function would actually look like this. A equals 1,000, 1 plus 0.025 over 1 raised to the 1 times t. So we don't really need that 1 right there. We just need a t right there. Now for the table, this will be your x and this will be your y. No, yes. And right now our y is the a. So you can change that if you want to. We can change that to say y right there. What's our x though? T. Now we like to use x because we're used to using x. X has always been our independent variable. The independent variable is the one that you choose and plug into the function. The dependent variable is dependent because it's dependent upon whatever the x is. And so here our independent variable, I should say, is t. So instead of t right there, we could put an x. Well, we know what the n is. It gets compounded once a year. The r is their rate. Our rate is 2.5%, so it's 0.025 as a decimal. And then our initial amount, which is p, is 1,000. And so here is our function, our equation.
How do we fill out the table?
Well, I mean, this is the question right here. How much money does the account have in the year 2033? Okay, so that means after 1 year, what year is it?
2014.
2014, okay. So if I put 1 right here, that would be 2014. 2 would be 2015. 3, 4. This is how many years passed. We have 5, 6, 7, 8, and 9, 10. And then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, find out how much money you would have every year. Okay, so what you're doing here is you're plugging in these x values right here, and you're plugging them into the time, which is we changed to x just so it looks like an equation we're used to seeing. So it'll be y equals 1,000 times 1 plus, let's simplify that, divided by 1 is just 0.025, raised to the 1 power. And the next time you would do it, you would raise it to the 2 power. And then you keep getting different amounts. Now, if you use your graphing calculator, you can plug this into the function window, which is the y equals window, then hit table, and then it'll give you all the values right here. So I'm going to fill those in really fast. Boom. There's all your values. Okay? So, now, if we're going from 2013 to 2033, that's how many years? From 2013 to 2033? 20 years. So after 20 years, you're going to have this much money in your account for just sitting there. Now, that's 20 years. That's kind of a long time. And you're only putting $1,000 in the beginning. But, hey, it's $638.60. That's how much you make for doing nothing. Okay, but and I kind of want to change the stakes here. Like what else can we do with this? So let's change something here. Instead of it compounding annually, that's once a year, let's have it compound monthly. What would that look like? Now, let's just do a second y, but this y is going to be green. Let's make the other one blue. Let's see, this one's a y. Okay, so this is a different one. How's that going to change? How's that going to change our formula? This was the blue equation right there. The green one's going to look like this now. It's going to go y equals, the 1,000 stays the same. We have the 1 plus, and the rate stays the same. How many times does it compound a year if it's compounding monthly? 12 times. So I have 12 times the number of years, which is t. Oh wait, but instead of t we wrote x, right? Yeah, instead of t we wrote x. So now, instead of filling out this whole table again, just because it's getting kind of obnoxious, let's just figure out this number right here. After 20 years, how much money would you have?
I didn't get that either.
Okay. Oh wait, hold on. This is not what you guys got? Okay, hold on. All right, that was the incorrect. We had a syntax error, which means we plugged it in wrong. It's $1,647.90. And so, did we gain that much more money when it was compounded monthly? Why doesn't that make sense?
You're right.
No, it's compounding. It's not like simple interest. Okay, let's try another one. Instead of it compounding monthly, let's say instead, not monthly, let's do continuously. Okay, we're going to use a different formula now. We're not going to use this other one. We're going to use y equals p times e to the rt. I always remember it by going y equals pert. Okay, so we have y equals 1,000 e to the point raised up. Let's see, raised to 0.025 times x. X is my independent variable, so that's what I put right there. What's the amount I would have after 20 years if it was compounded continuously?
Is this when we can plug in the e?
Yes, guys, this is when you're going to use the e. The e button looks like this, e to the x on your calculator. So if it's compounded continuously and you wait 20 years, this is how much you would make, $1,648.70.